Thank you for joining the May 2025 VMware TAM customer webinar. This webinar is organized by the VMware TAM organization to provide our customers the opportunity to interact with great speakers about content that will help them get the full benefit from their VMware software. Before we get into today's content, just a couple of announcements. Our next TAM customer webinar will be on June 12th, and we will have the privilege of being joined by Vincent Riccio to talk about VCF automation. You may also know this as ARIA automation or VRA before that. So if you're interested, your TAM should be sending you the details and registration link for this session soon, but please feel free to save the date. Your interaction during this webinar is important, so please make use of the Q&A feature to ask questions. If we're unable to answer your question during the webinar, please reach out to your TAM and ask them to follow up. At the end of today's session, you'll be prompted to fill out a survey related to the value you received from this session and topic suggestions for the future. Your completion of this survey is very valuable, and we greatly look forward to reading your comments. Lastly, this webinar is being recorded, and your TAM can make the recording link available to you. And after a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. And so there's a QR code to that channel and a link there on the page. Today, we have Matt just joining us again to talk about VCF Operations for networks. He was on the webinar back in March, kind of doing an overview of VCF operations for networks. Today, he's going to dig a little bit deeper into troubleshooting, specifically with ops for networks. But today, we're going to make the March session that he was on public facing just a little bit early. So that QR code and link will get you to that March session if you're interested. And with that, Matt, we'll turn it over to you, and we look forward to today's content.
Thank you. All right, so welcome everyone. As mentioned, my name is Matt Just. I'm a staff technical marketing architect here at VMware. I did deliver, as mentioned, a session back in March that focused specifically on VCF operations for networks and kind of an overview from a architecture, provided an overview from an architecture perspective, and also started diving into some of the use cases of VCF operations for networks and the benefits that it brings to providing true visibility into our network infrastructure, supporting our VCF infrastructure. That is obviously where our applications are residing in running from a virtualized standpoint, whether they be VMs or, excuse me, containers. So what the plan is for this session is I would like to continue on to where we left off. And as mentioned, you will have access to be able to review the previous session if you did miss that, where I covered more of the architecture and some of the other use cases around looking at flows and doing analysis for security planning. Also application discovery we touched on in the last session. And we kind of left off right before we got into the troubleshooting section. Because of the amount of use cases that the product does support within VCF and cover, it basically is kind of very difficult to cover it all within one session. So we decided to break this up into two different sessions. So as I mentioned, what I'll do is I'll just quickly touch on a high-level overview of the product itself, or I should say component. So some of you may have known the product that formerly as ARIA Operations for Networks or vRealize Network Insight. That has been now a component of VCF. So it is now VCF Operations for Networks or VCF Ops for Networks. And what we are doing is, within the VCF infrastructure, focusing on providing the visibility of network infrastructure and security infrastructure for various different roles within organizations and covering various different use cases. And what we're doing is, that's a little bit different than typical network monitoring tools, is utilizing a application-centric approach. So, a lot of tools focus strictly on the network and focus on specific, network needs and functions. While we do provide, the visibility into the network, we're looking at that from supporting the applications that our end users and, customers and tenants and so on, depending on the type of organization, are consuming and the performance of those applications as they reside and traverse the network infrastructure that we're responsible for. And that network infrastructure covers everything from the underlying infrastructure and also our overlaying infrastructure, which includes your VCF environment, which is, can be anything from virtual distributed switches to NSX overlay running within VCF, utilizing, routing and switching, P2V connectivity, logical switching overlays, and so on, and even getting into things like hybrid cloud extension. So getting into HCX, workload mobility capabilities between data centers and environments within your infrastructure. So we tie all that into ops for networks to be able to provide full stack visibility end to end, and including the underlying infrastructure that is supporting the applications that are running within the VCF infrastructure. So again, we break it up into two pieces. From an infrastructure centric perspective, we're looking at things like flow analysis, security planning within VCF or VMware Cloud Foundation. And as I mentioned, a lot of that's going to be kind of where we originally started, from NSX and the virtual distributed switch. And then we get into the NSX monitoring and troubleshooting. So as NSX, from an infrastructure standpoint, whether it's doing, north-south P2V type connectivity and routing between the overlay and the underlay, or if you have logical overlay deployed and extended L2 segments running within NSX, load balancing and so on, running within NSX, providing visibility into those components and performance and troubleshooting, along with how they correlate to the supporting underlying infrastructure, whether again it be anything from any of the major vendors that we support. So just pulling this slide up really quick, some of the major logos again of the various vendors that we work with and support within the product. So it's not just focusing on VMware product or VCF. It's also encompassing third-party integrations such as Cisco, Arista, Juniper, F5, and as you can see, various other load balancers and firewalls and so on, various different types of Kubernetes environments, and also tying in some of the other components such as HCX, NSX, vSphere, and so on, which are now all components of VCF. So as we go back to our slide here, the app-centric part, we've talked about getting into like the application discovery piece in the last session. So how we can utilize machine learning to use flows. And because we're doing a one-to-one flow ingestion and then, analysis, it's allowing us to use models to be able to discover applications and those application boundaries and dependencies, which is, really key in the aspect of understanding what does our application depend on, what type of DNS servers, NTP, what other types of applications is the application we're trying to focus on communicating with. And a lot of this comes into play with as we're trying to map out and make sure that our CMDBs are trued up, whether we're running like ServiceNow or something like that, or monitoring the applications within ops or networks, or if we're getting into even things like, as I mentioned, workload mobility and wanting to make sure that we truly understand all the dependencies that the application has and the components of the application, such as the VMs and so on, that what they're communicating with. And if we were to migrate the application from, let's say, a non-VCF infrastructure to a VCF infrastructure, are we going to impact that application? Are we missing something that application depends on, and being able to truly understand that? So that's where that application discovery piece comes in, is being able to utilize flows in full visibility analysis, being a time machine and being that we store the flows, we can run an analysis across those and be able to truly map out and discover and continue to monitor and discover the applications as the applications evolve. So as changes are made, developers make changes to applications all the time. We can see where there's different dependency changes, or where the application may have changed. It may not have as many, let's say, web front ends that it used to. They removed a VM, or it's evolved to running in Kubernetes. So all of those changes we're constantly monitoring and alerting and providing proactive notifications that we're seeing changes within the applications, and also any detection of new dependencies that we may want to take into consideration, both from a network performance perspective and also from a security perspective. And then when we get into looking at things like day two network operations, that's where we started to get into more of the getting into intent-based monitoring and some of the stuff that we're going to talk about today, which is going to be the troubleshooting. So we'll talk about what you'll hear is referred to assurance and verification, network assurance and verification, which is a tool set that combines guided network troubleshooting, application aware, and intent-based monitoring. So years ago, VMware acquired a company called Veriflow, and we actually integrated all that tool set within the VCF Operations for Networks product. So we actually have the intent-based engine that runs, where we can have out-of-the-box intents, and we can also have user-defined intents that are running against the infrastructure, and ensuring that we're meeting our business objectives, and whether they be from a networking or security perspective. And then tying into the troubleshooting piece. So that gets more into the guided network troubleshooting section that I'll touch on today. And then, continuous network monitoring, day in, day out, and being aware of how applications and our VCF infrastructure is performing, along with the underlying infrastructure supporting the applications running within that VCF infrastructure. Now, I'm going to try to answer some of these questions as I go, and then whatever questions I don't get to while I'm going here through the slides, just based on the amount of time, I will definitely get answers to all of these. But basically, so we see, when I say app-centric, I think APM, assuming that this does not compete with like Dynatrace. No. Yeah, so we're not an APM. So that's one of the things. Yeah, I can see where that can, be a little confusing, but we're not an APM. We're not, while we are focusing on the application, we're more focusing on the application from the network perspective. So we're a network monitoring and troubleshooting component of VCF, but the approach that we're taking is, let's take a look at let's pick an application, and let's start analyzing the network and how it's performing specific to that application, and cutting out some of the additional information, or I should say, non-essential information, and eliminating some of the overhead of troubleshooting. So, myself, coming from a networking engineering background, and also I've done many deployments and troubleshooting and so on as a network engineer. There's been a lot of disconnect in the past, where we get to the point where if we don't know the application, we don't know the VMware infrastructure or the virtualized infrastructure, the cloud infrastructure that the application resides in, we kind of lose visibility at that P2V connectivity standpoint. And trying to understand that is what the application is utilizing, what it depends on, and so on, is where we try to bridge that visibility. So that's where the app-centric approach comes. And you'll see that here as I start diving in. So really quick, I'll just click through these. In session one, we covered flow analysis and security planning. So how we can utilize the flows. We do ingest, IPFix, NetFlow, VPC info, and so on from NSX. Discovering and planning, we are vendor agnostic. We do not use any type of agents. Everything is all virtualized, appliance based, and allows us to have connectivity utilizing various different types of connectivity methods into both the VCF infrastructure components and the third party infrastructure that we tie into. We talked about that we do support IPv6, obviously, along with IPv4, and also look into like network infrastructure health and provide visibility into things like outliers and flow visibility of our top talkers and looking at things like round trip time metrics across TCP flows and so on, and provide proactive alerting. Now, we also touched on a bit on how we're also able to provide, flow mapping. So in that case, when I say flow mapping, not only just looking at the flow itself and how it, what the performance of the flow is from, let's say sessions to packet drops and so on, to total traffic performance, but being able to also click on a flow and have a automated, tool set that maps out the path that that flow takes. And that includes across the overlaying infrastructure and the underlying infrastructure. So we talked about how, we have a host here. This is an ESXi host. We can see the name of the host, the virtual machine. And then we can see where we have a virtualized firewall that is tied to that virtual machine. This is in a non-NSX infrastructure where, we're just utilizing a VLAN that is connected to a underlying top of rack switch, or could be various different components, but tying in from the PNIC to the actual going from our P2V standpoint, how that's being routed, where it's being routed to, and in this way, traversing various different overlay components, and as we get into like NSX overlay and extending L2 segments across NSX, which could be from like region to region, from the US to EMEA as an example, utilizing the overlay, how we're, what path we're taking, what logical routers are being hit, any type of firewalls that are being hit that are running within the VCF infrastructure on the overlay standpoint, from an overlay standpoint, and then as we arrive at our destination. So showing the paths that the flow is taking to, from point A to point B. So that also is a benefit, when we look at troubleshooting. So as we now, do analysis on these types of paths, we also see these red triangles that pop up here. And we talked about this briefly, where when one of these triangles appear in the path, that is where we're also detecting an alert or some type of anomaly on that associated device in the path, whether it be in the virtual infrastructure or the physical infrastructure. And we can click into that and start looking at what is going on. Is it something like where we're running jumbo frames in the VCF infrastructure and we're not running jumbo frames in our underlying network, where we have an MTU mismatch and so on? So we're looking at things like that, or do we have a routing configuration issue with BGP, between NSX and the underlying infrastructure? Various different things that could be going wrong, or performing issues, or performance issues, or it could be something, simple as, hey, we're pruning VLANs here, and we want to make sure that we're, the VLAN pruning within NSX, resides so that we don't have any mismatches across the trunks. So we want to look at that and make sure that, we don't have any mismatches there, and we'll call those out utilizing things like intents. We also dove into the application discovery piece, and how we can utilize the machine learning capabilities to discover applications, how we can go through different confidence levels, tiers, the number of VMs that are being associated. And as those are being discovered, we can then save those and start monitoring those inside ops for networks. And we can also utilize those as we're discovering to kind of compare to, like we have a ServiceNow CMDB direct integration, where we can take the CMDB that's currently defined within, let's say ServiceNow, and import that, and then compare it to and utilize that to true up if we're seeing additional types of dependencies, especially like on an older application that may have not truly been fully discovered in the past, from a mapping perspective, being able to make sure that that is trued up and updated. I do see some of the questions come in. How well does this show flows from the native public cloud and things like AVS, GCVE, et cetera? So currently we do support AVS and GCVE. So if a public cloud infrastructure is running the VCF stack within that infrastructure, which would be, obviously AVS or GCVE or VCF on AWS and so on. We do provide full visibility there, and so we can see all the same flows because it's essentially running VCF on hypervisor or hyperscaler, and that's there is no problem there is providing that same level of visibility and troubleshooting capabilities. Now, getting into just like native public cloud, we do not support native public cloud within the product. We do have other products that actually dive into just strictly public cloud monitoring infrastructure, where applications are tied in. This specific component is a component of VCF. So again, decouple the concept of this is not a separate product like it once was in the past, where we did have public cloud monitoring. This is now a component, operations for networks is now a component of VCF and focuses on the VCF infrastructure and the applications and the network that are supporting those infrastructures. And that could be whether it's living in your data center or if it's deployed in public cloud on hyperscaler running the VMware VCF stack. With license portability, you obviously have those capabilities of doing that. So we've got that one taken care of. And then are you able to monitor physical devices outside of the data center environment, such as LAN, WAN environment? Yeah, so I mean, we can monitor those different devices, but again, when it goes outside the data center, it depends on who's managing those devices. So if it's your own infrastructure, absolutely. I mean, we can get into looking at LAN WAN connectivity, and we do have that capability. So if we're going from data center to data center, um, absolutely. Now, when you get into infrastructure that is being, managed by a third party vendor, let's say an AT&T or a cloud provider or someone, depending on what type of access they provide to those devices, will determine on how much we're going to get. Now we'll see the flows end to end, that's not a problem. But if you're looking at like routing tables and so on, and you want to see, getting into like MPLS infrastructure and that type of stuff, um, it depends on if the service provider will provide access. And typically, depending on the vendor, it's going to require like SSH read only, SNMP read only type metrics, or it could even be API based metrics that we're pulling from that device. Now, if you own the infrastructure and you manage the infrastructure yourself, then yeah, it's not a problem. Let's see. Could this be used to diagram our virtual data centers like network diagram done in Visio? Any good solutions for mapping out a VMware environment? No, it's actually a really good question. So the answer is yes and no in this one. So yes, we can map out the environment, and we do have what we call the network map, which is a component of Veriflow that when we acquired them, that we integrated in, so we can actually map out all of the paths and both L2, L3 mappings between the virtual infrastructure and the physical infrastructure and show that in its entirety. Does it currently have a way to export it to a Visio diagram today? No. Is that something on the roadmap? I'm not sure. That's something our product management team would have to, compliment or, comment on. It may be, I'm not sure, but we do have the capability of doing the maps. You can fully customize the maps, adjust the layouts, build different maps at different, of different infrastructure that you may want to focus on or have the full infrastructure mapped out for you. And it does it automatically. So once we run an auto discovery or you manually add the devices in your infrastructure, you can do that either way. It'll basically comb and climb the network and discover all of the connectivity, and map that out dynamically for you. So you don't have to do it yourself, and then show you basically where we're seeing connectivity. And then you can start using like intents and so on and against those mappings, and doing analysis and being alerting if someone makes a configuration change or if a path changes and so on. Or let's say from a security perspective, if we set an intent, that, hey, point A to point B should be segmented, whether it's in, NSX or in the overlay, or if it's on, let's say, a Cisco ASA firewall in the underlay, um, we want to be alerted if someone makes a configuration change that could potentially allow a flow or a session to reach point A to point B. We can run intents against that mapping to be able to determine, if that has occurred, and be proactive on that and alert upon that. So, but as far as exporting to Visio, not today. The let's see, what specific path flow analysis does VCF NSX troubleshooting provide? Than what is in the native NSX with trace flow live traffic analysis? So good question. On that one there, so NSX does have some tool sets that will allow you to run, trace routes and live trace paths. Typically, it's from like a point A to point B perspective. So you're doing analysis from a specific VM to a VM and within NSX. So there are some tool sets there, and there are some overlap with that. Now, where the difference is VCF, NSX is a component of VCF now, and same with Opstra Networks. So Opstra Networks is tied into and scales at a larger scale from a network monitoring perspective, and also encompasses the physical networking underlay. So if that path is doing L3 and going through the underlying infrastructure and not staying just in the overlay, that's where we're going to bring in additional visibility. So you'll still get your trace flows and you're still going to get your live traffic analysis in NSX, but where Opstra Networks comes in is it's going to have the capability of also mapping out and including those underlying devices and their performance and configurations and so on to better help troubleshoot and call out where we're seeing issues that could be impacting that application. So typically, some people may start, that like to jump right into NSX and use that tool set. They may, and then they say, hey, we need to expand the visibility. So they'll go to Opstra Networks within VCF and expand that. Or it might be the other way around. If we're in a NOC or a SOC and we're monitoring the infrastructure from that, typically customers are utilizing Opstra Networks to start. And then if they need to dive further into different tool sets within NSX, they can absolutely do that within VCF. We had a challenge where we can only monitor the VMware side of the conversation and have been advised that we need to be able to monitor the whole network flow, switches, routers, cloud flows to monitor the latency. Why is this a requirement? I understand that we're able to show part of it causing the latency needs full monitoring, but I should be able to at least see RTT at the flows going to an unmonitored destination. So absolutely, you're correct on that. You do not have to have the physical underlay added to see the flows TCP round trip time as an example. So if the flow or excuse me originates or terminates from a member of VCF, so let's say it's a virtual machine running in an application within VCF that is communicating with an external IP address, okay, or an external database that is running on bare metal, and you don't have the networking underlay added as devices or data sources, as we refer to them, within the product. You'll still be able to see the full flow TCP round trip time analysis. That comes from VCF itself. So we actually pull and are monitoring that data from the from the VM itself to the source, and whether it's a source or destination, and we can see that TCP round trip time. Now, getting into like latency hop by hop, that's a different area. So if you're looking at as that flow leaves the overlay, the virtualized infrastructure, and goes hop by hop through multiple router switches, load balancers, and so on, their physical devices, you're not going to have the latency metrics at each hop in regards to, because you don't have access to those devices from a tool set perspective. So will that impact full flow, end to end total response time? No. It's more for if you're looking to do it from a hop to hop latency perspective, like, how much time did it take to get from this router to this switch and, to this load balancer that are running as physical devices. That's where you need to have the physical devices added in the underlay to be able to gain more visibility into that type of latency. Full flow round trip time latency, you'll definitely get in the product without the physical network being added. Excuse me. Mapping environment may be key for HIPAA starting this year. We are hoping that VRNI can help generate that for us. So yeah, the mapping environment can absolutely provide the full mapping visibility, and you can utilize that for HIPAA compliance and Now, do we specifically call out compliance for HIPAA inside the product itself? No. Are there other components within VCF that do focus on compliance and HIPAA? Yes. So, like in VCF Operations, there are packs that will focus on that, and all of this ties in together. So you could do analysis if you wanted to monitor specific compliance packs and standards against your VCF infrastructure. Where we're from a networking perspective, your applications that require, to compliance for HIPAA, you'll be able to actually have full mapping visibility and so on, and utilize those exports to be able to provide for compliance reports and so on as required. You mentioned Federation support. Does that now mean global manager is added as source? So no. So with the Federation, you do not have to add the GM. Basically, you add the NSX managers at each destination or at each location, and we auto detect the GM, the global manager, and we can basically build the full federated infrastructure modeling right inside the product. So we do not need the global manager. You just add each site's NSX manager, and then it will automatically detect and map that out and provide that monitoring. So that's an auto detection standpoint. For mapping, we'll use SNMP v3, NetFlow, and other. Yes, absolutely. So for mapping, we can use SNMP v3, 2. We use NetFlow, SFlow, IP fix data, and then we also use configuration data. So we also will look at, if we're doing a CLI scrape as an example across an older device, or if you're running, let's say, Cisco ACI and it's being managed by APIX, we're actually doing API calls to the APIC and pulling data through the APIC itself rather than going to each individual device. And we can utilize all of that data to provide the mapping capabilities. So whatever is the least resource consuming to any type of third-party vendor perspective is the approach that we take. So if they provide an API, we use the API. If it's something that we can do via CLI, SSH type access, we can do that. If it's just SNMP, we can do that. If it's just analysis off of flows, we support that also. So yes, we have various different ways that we can pull all that information in. Will UCSX and intersite managed mode be supported as a data source in the future, ETA? That I am not sure. I do not have an answer on that question, but you can actually, we can pose that with the account team, your account team, and we can get with product management and ask them if there are any plans to be able to support that data source in the future. They would be the ones to be able to answer that and also provide an ETA if there is. I'm not sure on that one there. Okay, so continuing on, and just looking at, for the sake of time, where we kind of left off and what I wanted to jump into is more of the day two network operations and the guided network troubleshooting tool set, because it is a very powerful tool set that helps us become, aware of anomalies that are going on within our infrastructure and where those reside, whether it's in the VCF infrastructure or the underlying infrastructure, and tying in performance metrics and alerts that are coming in, and how we can actually utilize this to open incidents and from a troubleshooting case perspective, and work across multiple teams that can access the tool set within VCF and be able to work together to be able to look at various different components and troubleshoot performance issues depending on where we're seeing anomalies, and calling that out is where we can start to make a determination on who needs to be involved, or do we need to collaborate with another team on this ticket, and kind of go in and how it can be utilized to create and monitor tickets and events, troubleshooting incidents, and how they're historically saved, and if a similar problem arises, you can quickly access the historical tickets to be able to look at, hey, what was the problem and how do we resolve it, and utilize that for quicker mean time to innocence, obviously. So let me swing over to our environment here. And what I'm going to do is, we'll start from the main application dashboard. So when we log into Opstra Networks, we're going to see, and obviously an overlay or an overview of our main dashboard. And again, we talked about this in the first session, how everyone can have every end user that has access because we use, VIDM or we use Active Directory integration excuse me, can have customized dashboards that are specific to their job role, as an example, or data sets that they want to see. So you do have create new dashboard capability, and you can choose any type of data, whether it's an already populated, we call these widgets. You can see you can actually grab these widgets here, and you can move them around and reposition, utilizing HTML5 capabilities in the browser, and you can save those, or you can take one of these and say, hey, I want insights to be on my dashboard, but I don't care about anomalies, as an example, or the infrastructure performance of Opstra Networks itself. So you can actually pin this and pin that to a new dashboard or a recently modified dashboard that you have. And then each user, when they log in, can access those specific dashboards. You can also take those dashboards, let's say you're doing a troubleshooting incident and you're seeing specific data, anomalies, or I do a search query here for a specific, flow that I want to focus on, or any type of data within the product, all can be pinned to a dashboard. And that could be just for specific related to, let's say, a troubleshooting incident. So I can create a dashboard, name, give it a name, and then I can share that with anyone that has access to Opstra networks, as an example within VCF. So I can, share it to specific people, or I can share it to an entire team via, email, and also push a notification within the actual product if they're constantly in the product or the tool set and monitoring the infrastructure. So what I'm going to do here is I'm going to jump in and we'll go to, let's say, from an application perspective. So, uh, excuse me. So let's say we get a call, from a end user that's saying, hey, they're having, performance issues, they're seeing problems with an application, or multiple end users are calling. So we can come into our application dashboard, and this is where we touched on this in the past, but where we monitor and we can see, the overall health and performance from a network perspective, supporting our applications. And so we've already discovered our applications. We know which ones are on premises, hybrid, cloud, and so on. And we're seeing if there's any anomalies being detected already, being called out. 14 applications, 4 of them are detected right now with anomalies or possible issues. And then we're also seeing things like, security. We have unprotected flows. Okay, well, what applications, are those unprotected flows in? So here's my application, how many flows, and I can launch into plan security if I'm getting into a security type analysis and implementing firewall rules and so on. We can also see how many applications have critical problems. We can also see how many troubleshooting incidents. So this is where we're going to dive into the guided network troubleshooting, in progress, unresolved. And then we have a dashboard that calls out anomalies. So basically, this is looking at our top 25 applications, and it's looking at various different anomalies that we're detecting. So whether it starts from a critical problem perspective, or if I want to look at things like outgoing traffic. So I want to see which application has the most outgoing traffic right now. And I can see this Windows 11 VMs group where someone created an application, added a bunch of Windows 11 machines to it, and it's specifically calling in the application just to monitor it as a group. We're seeing how much outgoing traffic and what the increase was. And then we can also see other applications like our shopping cart and how much traffic, what was the increase over the last 24 hours. Various different metrics that we can use, incoming, failed intents, retransmission ratio or rates, round trip time. So we can see who's got the longest, and we can see the application name. We can see what is the maximum TCP round trip time that we're seeing within that application. And we can dive in right from here and click into the dashboard or troubleshoot to see, why we're seeing such high latency. We can also look at, traffic from the internet. So we can see which ones have the most coming from the internet. So this is coming in again to various different applications, how much traffic, the number of flows, and all of these, they're blue on my screen. They may look green to you. But either way, these are dynamic links. We can click into these and look at each individual flow that's going into this application or members of the application and see what's going on there from the internet. And then same thing, traffic going out to the internet. So we can utilize this to kind of focus on our applications from a top 25 perspective. But most importantly, from a troubleshooting, our critical problems. So I can come in here and I can see that I've got some issues going on right now with 5 different applications, and how many problems are being detected in each application. So what we'll do is I'm going to pick on our shopping cart as an example. We see we've got one critical problem currently going on. So from here, I can go in and say, you know what, I want to start off, let's look at the application dashboard itself. So what this is doing is this is now pulling out an overview of the application, and it's giving me an overview of how many alerts are currently do we have that are critical, how much traffic is incoming, how much is outgoing, what is the changes over the last 24 hours. You can see the percentages, how many flows are currently active within this application, how many of them are unprotected or hitting a denied firewall rule, intents that are configured against this application. How many countries is this in, are, from, let's say, flows going out to the internet are, that we're interacting? Where's the majority of the traffic going? We can see to the United Kingdom in this case, then Ireland, and then the United States. And so we can actually click in and look at each one of these. So this provides visibility into and also helps us isolate down, depending on where the end user's at, looking at specific flows related to that end user that may be accessing the application, or a database that's accessing the application from another site. It just as an example. And then also, how, what does this application, you know, what makes up the application? Is it a number of virtual machines, physical IPs, and Kubernetes services? As we scroll further down, we have our application dashboard. Excuse me again. These are our tiers. So this is our web tier, our database tier, our application tier. We can see shared virtual infrastructure, internet. We can see others, which are going to be VMs, physical IPs, or other VMs, or other members of applications, and so on. Then we can click into each one of these to start looking at and these are all flows being represented. So, from our app tier, if I come in and click keep focus, I can see I've got flows from members within my app tier, which there's only one member in this app tier, going to shared virtual, down to the web tier. There's also going to the DB tier and also to others, but I do not have any traffic from the app tier going out to the internet. And then I can decide if I wanted to do analysis specifically, and let's say I just wanted to look at traffic going between the app tier and the web tier. So this is showing me from the web tier to the app tier. I can see my endpoints, how many flows, total traffic, and then I can start clicking in and doing analysis on these flows as an example. So some of the ways that you can do this, but we can go much granular utilizing things like guided network troubleshooting, which I'm going to click into here, to be able to more mind map this out and be able to diagnose what's going on and with the application. We also, because we know what makes up the application, we can also then correlate all alerts, configuration changes, whether it's in the underlay or the overlay. So, instance, we see configuration changes. We can see properties that were changed. So, someone was in the NSX policy group, changed some security groups in the NSX policy groups where they added various different members and so on. We can see these grayed out analytic alerts. So these are showing where we are seeing changes in TCP round trip time on specific components of the application. And we can click view chart to do analysis and see where we are seeing deviation spikes. So we will do auto detection using machine learning and analysis, where if we start to see, we'll baseline the performance of various different metrics. And if we start to see deviations from the baseline, we'll alert those and trigger an alert to make you aware. So these are all past events. I mean, these can go up to, I can click on, 1 month if I want to go back or even further, and I can look at all the events for this application that have occurred and specific to only components of the application. So when I say components, I'm talking about it could be the VMs, it could be the NSX infrastructure, it could be the VCF infrastructure, virtual distributed switches, it could be the underlying, routing and switching, load balancing, or internet-related performance problems. So we'll take all of that and pull it in and associate specific to this application, so you don't have to go diving through the entire infrastructure trying to find each one of the alerts associated to traffic going in and out to the application. And then we also provide visibility into the application member managers. So that's going to be things like the vCenter that the application's managed by, or the NSX manager, and so on. And then, what their versions are, performance, that kind of stuff. So we're showing basically what manages the application. Now, there's other metrics that we can put, right inside the application dashboard that we can use. We can look at incoming and outgoing traffic. We can look at various different metrics as to like things like network traffic rate, and we can filter down like on, if I care about things like how much consumed memory is being used and so on, or CPU ready rate, that's going to be more on the compute side. Or if I want to get into, network metrics, I can come down into network and I can do, what is the status? What is the default gateway router? And focus on specific components for each one of the VMs, TCP sessions, incomplete, layer 2 networks, logical switches, and so on, MAC addresses, network traffic rate. So as I click on each one of these, it's going to add that to the graph so I can see the max network traffic rate and then the average network traffic rate. So here's my average over the last 24 hours. And then here's my maximum over the past 24 hours. And I can also see all the performance metrics there. And then if I wanted to go further in, I can click in on this specific member, which is a web VM that's running within the application. And I can go deeper further into that specific flow and do analysis. So many different metrics that we can focus on. We can also look at flow, what are our top talkers in the last 24 hours? So here's the member. So this could be a physical IP, it could be a VM. It will identify it. It'll tell you if it's a VM or a physical IP or a Kubernetes service. So in this case here, it's showing me this specific web VM has 21 flows. It is our top talker. It has 92.5 gigs of traffic over the last 24 hours. We can also see top application flows by rule. So these are actually NSX firewall rules that are running within the infrastructure. It's actually showing us what rules are being hit and how many flows are hitting those rules, and also giving us an overview of the total traffic. And then if I wanted to click into a specific rule and look at more metrics on from a security perspective, I can. And then lastly, we can do our intents and define intents. But what I want to do is, from the overview perspective, let's go ahead and click into troubleshooting. So this is where we can say, okay, I want to troubleshoot this application. I've got one critical alert. I want to go ahead and look at this application. We'll start with the last 24 hours, so, based off of data. You can also adjust this and select a time range, or you can come in and, pick, a range, or you can come in and do custom. If you click on custom, it's going to let you set a start date and an end date that you're going to, do analysis on. So depending on when the issue actually took place or was reported, we can set specific timelines that we want to focus on. We can give the incident a name. Now it's automatically just going to start and call it troubleshoot dash application shopping cart, PVE shopping cart, or I can name this because it's going to be the incident name that's going to be saved into the ticket. You can also see opened, or these are continued from previous incidents, and you can see other incidents that have been opened and the date range and so on, and which user actually created these and opened these tickets. Okay, so we're tracking if there's any open incidents, and we can click into these to start looking at what's going on and what they're troubleshooting. But if I click on Start New, what we do here is we take we use a couple different tool sets. So we're using a mind mapping approach to say where we're starting off, because I chose, and we can start from any type of device. So if let's say I immediately go to a router and I want to start from a router or switch, I can. If I want to start from the application, which I chose to do, this is where I can see everything that the application resides or traverses or depends on. So here's my application, okay? And then it's breaking out and telling me how many VMs. There's 11 VMs, 6 physical hosts across those 11 VMs, how many flows, how many NSXT edge VMs, transport nodes. So this is going to be my VCF infrastructure. And then it's also showing me things like services, what services, external services or internal, VM-based services are being accessed, that I can click into and start, expanding upon. Now, for instance, and then we can oversee on the right side here, we can automatically see that there's been anomalies detected. And anything lit up in red here is an actual anomaly. So this is actually showing me on the network transmit rate or receive rate for the actual application here. So it's calling out what it's looking at, the application itself, that we are detecting anomalies. And I can say, okay, just show me the anomalies. There's 51, and it's basically showing me where we started detecting anomalies. So you can see right here, we had a increase in received traffic where from the baseline, we were averaging 1.2, 1.3 megabits per second. And then we automatically, had a spike where we were jumping up to a higher rate of traffic into 2.6, which deviates from its typical standard. Now that may not be nothing, but at the same point, we're calling that out and making you aware that we are seeing a deviated based on the specific amount of time that it took to deviate. Same thing when it goes to things like you're looking at your application retransmitted packet ratios, as we're starting to see those. When we're seeing network packet drop increase, so we can see, we've got some packet drop, low percentage, but then all of a sudden we spike up to 4.7%. And we can see the time range and so on. And the nice thing is we can start to correlate these across various different metrics, or whether it's, in this case, we're looking at the shopping cart, the actual application, this is actually showing us that this actual network packet drop is related to the actual web VM, a member of the application. So we started seeing packet drop increase here, and then similar again here where it spiked and triggered an anomaly. Further down, we can continue scrolling, and again, focusing on the application, it's showing us more network packet drop, and this is going to be for the other web front end. So you can see the name of the VM is different. It's web 3565 and 4147, and it's showing us a comparison, okay, between the two. It's also showing us things like network traffic rate. So this is now a specific another VM where it's showing us burst increase of traffic, and we can see that that also corresponded up to where we started seeing the application also started seeing on the receive side. We can also further, as we come down, look at things like network traffic rate of different components, TCP retransmission ratios, where we're seeing specific to a flow. So this flow here, it's from 10.138, so it's giving you the IP address, and it will also give you the DNS naming. So in this case, this is a virtual machine that's running within the application to the web front end of the application on port 80. We were seeing a increase in TCP retransmission ratio, and we can come in and we can see where that increase and how much that was and where it's flagging a anomaly. Further down, average TCP round trip time. So getting into latency. This is again a flow from a member of the application to the web front end on port 80. We started seeing a high increase of latency from its baseline. So we were down at 13.6 milliseconds, and now we're jumping up into seconds itself. So we're flagging those anomalies and calling those out. Now, where does all this tie in? Again, this is looking at the entire application from a whole. And down here, we have also alerts. So we're tracking all of the alerts and changes made within an application, both in the VCF infrastructure and the underlying infrastructure. So I can tie these and I can look at these compared to the timeline. Like for instance, this is a configuration change. So if I come in here and I click view details, I can come up and I can look and see what happened 12 hours ago. We had a change, and this is where that NSX policy group was added, and a security group was added and associated to the specific VM, which is a member of the application. So if that was a configuration change that impacted the application, I'm also going to see corresponding alerts around that same time. We can also see critical alerts that we're going on. We can see also non-critical alerts. Some of these can be best practice. Someone used the password for the user audit is approaching expiration in 30 days. So those are just non-critical alerts that are being called out, but they're called out on the alert dashboard here, and we can click into each one of these to see what they are. So this is an analytic threshold alert. We can click and see what this was within the application. And again, this is focusing on the threshold violation detected between for a specific VM within the application under its flow round trip time. And we can see that it baseline upper bound um, was, from range was at 200. And then as we go, we can start seeing where here now we started to deviate and get into milliseconds. So we deviated from our standard, and you can adjust the alerting time. So you can set your violation durations. Some applications can be very chatty and jump all over the place, but you can actually, as you start, as the product starts learning, it'll dynamically adjust. Or you can come in and say, hey, don't alert me or call a anomaly unless the violation duration is for more than 5 minutes, as an example. So you can define those. Now, what we also have is the capability up here. You can see what this is showing me is it's showing me the status of this ticket. So this incident, it's in progress. It's showing me, have we determined any root cause metrics, any root cause alerts, any closing remarks? So that would be if we close the ticket, the date the ticket was created, who created it, last time it was updated, updated by, and it's going to tell you the starting entity. So I started with the shopping cart application. It's going to give you also some information on what was at that time of the incident, what was the total traffic flows, and any past incidents. So this is where I was talking about looking at incident history and determining, do we have similar incidents that are occurring that we want to focus on. Now, we also have troubleshooting insights. And what these insights are, these are what we call quick scans, where they're going to be some of the ones that we're looking at that we consider the top most possible cause that can be causing, alerts and anomalies to be detected on this application, where it's looking at things like your average TCP retransmitted packet ratio for the application. They correlated it. So if we hit the analyze on here, it correlated to the TCP retransmission ratio of the database running in the application. Here's the IP address, the port, and we're seeing a comparison of those metrics. So we're looking at the average TCP retransmitted packet ratio versus TCP retransmission ratio. So we can utilize this data to look at the correlation. And again, so we can see here, TCP retransmission ratio is 1.4%, or the average TCP retransmitted packet ratio. And these are what it's doing the comparison. This is the application itself on the average TCP retransmitted packet ratio. And this is just a specific flow or flows going to the actual database itself. So, and it's looking at the TCP retransmission ratio maximums and doing a correlated analysis and to as like a first step as to where we could look. It's also going to call out the second and third, it ranks them. So it's also going to show us other anomalies detected in TCP retransmission ratios. Again, this is on another virtual machine within the application. It's telling us what port, what service was impacted. And then we can also see anomaly detected on TCP retransmission ratio of a physical IP, which is basically one of our service endpoints. And we can see when there was active traffic. And, at one point it was at 14.9 seconds, and then all of a sudden it dropped down to basically nothing, milliseconds. So it's showing you where it's seeing the deviations occurring and calling those out. Now, what we can do here is we can come into the mapping, and I can say, okay, well, I know, right now we got a lot of stuff in red. And this is because we have many users in this lab that are constantly going in here and purposely changing things and breaking things for demos. But typically you're not going to have something all lit up this red when you come into an application. Being a lab, you're going to see it in this one. Now, as we come in, I can come in and I can say, okay, we've got the 11 VMs here. Now I opened up and I can see all the virtual machines that make up this application. So I can scroll through the different pages and see which app or all the different members that make up this application. So database, again, we can see the various different web VMs. We can see our other database VMs and so on that make up the application. The ones lit up in red here are ones that we've detected anomalies on. So again, as I click on, let's say this web VM, here's the anomaly that we detected. Network packet drop percentage for this VM, increased to 4.7%, which was a deviation from its baseline of typically no more than, very minimal amount of packet drop. So I may want to expand upon that and start diagnosing what might be causing that packet drop on that for this member of this application. When I expand this, this is where it's now letting me look at, okay, here's components that this VM is utilizing or depends on. So it's giving me the flows that are occurring for this VM at that specific time. And we can see the one flow that has an issue. Oh, hopefully my VPN connection didn't just drop. Go back into that incident. Looks like it's still up. Okay. So again, as we expand that, we can see the correlated dependencies for this specific VM that is having anomalies that we're detecting. And then we can see the number of flows, the local services, the remote services. Are there any NSXT Edge VMs that this VM utilizes? Transport nodes, router interfaces, logical ports, logical switch. These are your physical vSphere hosts. Any peer VMs that reside on the same host that this VM resides on. So I can do like, hey, are any other VMs experiencing issues that reside on that same physical host? We don't see anything lit up on the host or the peer VM, so we know there's not an issue there. Right now, it's just calling this out on the remote services side, so I can expand on the remote services side to look at what was the actual remote service. So in this case here, it's a DNS server, what we're seeing performance issues. So it's reaching out to the specific IP address, port 53 DNS, so I know that's a DNS server, obviously. And I can click on that and I can see what the anomaly was specific to that service endpoint. So in this case here, we started seeing an increase in sessions where we were running at a minimum of 105, and then all of a sudden we jumped up and started increasing number of sessions from its standard baseline. So it's calling out that as an anomaly, and then we could utilize that to start going further again and expand that on that endpoint and dive in further. How many flows for that endpoint? How many VMs or does that endpoint tie to, which is specifically our web VM here. So we can mind map out all of the dependencies that correspond to an application, or let's say, from a network perspective, let's say I want to choose and just focus on a specific router or port or within the infrastructure. You can actually launch a troubleshooting incident from anywhere within the infrastructure. So in as an example, when we click onto the host here, if I wanted to start from a host perspective, I could do that. I can see that this application uses 6 different hosts. It's got VMs spread across 6 different hosts. And if I wanted to look at the hosts themselves and I wanted to look at how many VMs are on each host, the host itself, the switch ports. So now I can now see my switch ports for that host. I can expand on the switch ports. And then I can also come in and I can see the switch port itself, click on it, and I can look at, what was the received packet drop, what was the network RX rate, and so on for that specific switch port on that host. Now, this is going to be tied specifically to, the switch port, which is going to be a VM NIC. So this is showing me VM NIC 1. And then as I look at this one here, this one, when I click on info, this is VM NIC 3. So you can click on each one of these and you can look at each one to look at what are the metrics. So I can see, okay, here we do have anomalies on VM NIC 3, where we're seeing the web VM is increased network packet drop going across that specific VM NIC. We're also seeing network packet drop being detected, RX packets being dropped for different VMs and so on that are traversing the specific VM NIC. So we can utilize this data to correlate and look at where we may potentially have a problem. Now, this being tied to an underlay device, it could be something running in the underlay, and we would flag that also. Now, I don't have an underlay device added for this specific application or underlay devices, so that's why I'm not seeing the connectivity there. But if I did have it added in the infrastructure, it would show me then start expanding further into the underlying infrastructure. As we go further down, we can also see various different other components. Flows, we can look at our NSX Edge VMs. So these are going to be our edges, which are going to be dealing with all our routing and so on. We can expand across the various different edges, and we can see where we've got edge flows that are, we're seeing some issues. So I can expand across those. And on the edge flows, I can see where we've got, specific flows. It's telling me what flow it is, source to destination, what port between it, whether it's two VMs or in this case, it's a VM to a physical IP. And it's showing me here where the TCP retransmission ratio for that specific VM experienced an increase from its baseline. As I scroll further down, it's also showing me other just performance metrics, the traffic rate and so on, just to see if there's anything that I can correlate or that I may want to call out, but it's providing you with all the metrics related to that specific edge flow. You can also see the host that edge is currently residing on. You can see the pure VMs again that edge has on that same host, and we can dive into various different metrics. Same things with your transport nodes. Again, these are going to be your routing or your networking components running inside your VCF infrastructure related to the NSX infrastructure, and we can start clicking in and looking at performance metrics here. And this helps us again look at and see, do we have any correlated alerts that were active at that time, and looking at what was going on. Again, there's a lot of noise in this application right now because of the essence that it is a lab, and there are a lot of people in here doing demos and breaking things on purpose to cause issues for demo purposes. But we can absolutely come in and dive in and look at various different dependencies and metrics, which is very important when you're going in and troubleshooting an application and trying to understand everything that that application depends on and what components in our network infrastructure, whether it's in the overlay or the underlay, um, that we want to jump into, whether it's flow related or component related, whether it's a switch port or a host that's performing badly, that may be impacting. Because again, now that we're running virtualized networking in the overlay, as an example, you may, if you have a host that is having a disk problem and there's an issue performance, that could be impacting the performance of, let's say, an edge router. It's going to show us that correlation and tie it back to that, hey, this application is being impacted because of that specific problem. So it could be related again to the virtual infrastructure. And that's where I talk about tying in with various different teams. So down here at the bottom, this is where we can start typing in notes as we're observing. This could be a multi-team troubleshooting session where I could have my virtual admins inside the infrastructure, and they could be, providing notes, like VM I can type in a bunch of notes, or if that I looked at on specific, related to a VM or let's say a switch port. And then as I click add, it's going to use the user based on what they were logged in as, tell you who put it in there and what the node is, and they will stay part of the actual incident. And teams can work together and collaborate and put indications and alert others, saying, hey, I need Joe to check out this Cisco top rack switch port number 1/42, because I'm seeing that we're seeing packet drop on that port, and in that application, and according to this mapping, the application is traversing that port, so we need to do analysis there, and I need a network engineer to take a look at that. So we can then, the networking engineer can then log in and utilize the same tool set to come in and click into specific data sets related to that, let's say, a top rack switch, or underlying router that may be related to the application that we're seeing issues, and start doing diagnostics into what's going on there, looking at metrics and performance metrics that we're getting from those devices to determine, is there an issue there on that actual device itself. Close this up. And let me go through these questions really quick here, because I know we're just getting past the top of the hour. Integration to various internal components sometimes depends on various configuration and endpoint. Also with authentication based on certificate, other method. And do we have a centralized page to look into this more granular level and understand the overall configuration and health aspects along with authentication aspects? So, yeah, so the answer on that one is we do. So you're absolutely right. Depending on the components, um, there's going to be different configurations and different, when you get into authentication based methods and so on. So when we get into doing accounts and data sources and adding those components, we can do that manually where I can come in and do like a single source and it will tell me what is required for every one of those. So as I come in, from a vCenter to an NSX manager, HCX, or let's say I go down and get into like my routers and switches. I can come in and I can pick on like let's say I want to add a Cisco Nexus 7K. It's now going to say for this 7K, these are here's the instructions. We'll give you an overview of what we need connectivity, SNMP, read only, SSH, and so on, specifically to the Nexus 7K, the SNMP versions. What we'll need, if we're going to use version 2 versus version 3. This is allowing you to choose the collector VM, provide an IP address or an FQDN of that switch, a read-only username and password. We validate and then go to the additional information where we can do like adding SNMP credentials and so on, and then submit and add that device if we wanted to do it in a manual way. We also have device auto discovery. So this is where you can actually come in and you can define profiles. So if you come into discovery profiles, you can create a discovery profile. And this is where you can choose like how do you want to discover devices or infrastructure. You can do your seed IP, a scan and IP range. You can also set specific, IP addresses, what collector is going to scan them. Do I want to add any exclusions? Do I want to add any more? What is the discovery depth that I want to go? So you can actually set your depth. You can then click on, after you define these, you can click next. On the access, you can actually set up different profiles. So you can set up profiles that require or usernames and passwords and so on, or specific credentials that may be required, whether it's certificate related or credential related, depending on what type of device and what we're going to be scanning. You can define those profiles, and then you can also set your scheduled discovery. So you can name it, and then you can set a schedule that it's going to run on. And then it's going to go through and it's going to run. And as it runs, it's going to then start populating all the discovered devices, whether they're virtualized or physical devices in the underlying infrastructure, if we're doing both. So it'll call out the vCenters, it'll call out the NSX managers, it's going to call out every component that's running in VCF. And then it's going to start, for discovering the underlying infrastructure, it's going to say, hey, we found this Nexus switch, this Juniper router, this Cisco ASA. And it's going to populate all those, and then we can click add and start monitoring those within the actual infrastructure. So we have multiple different ways that we can actually discover devices and so on. So next question is insight specific to VMware tools. Does it work with hardware firewalls, Palo Alto? Yes and yes. So when we're looking at VMware or VMs and stuff, if VMware tools is installed, it's an extra hook that provides data set. So we will pull data from it. To be honest, vCenter is actually doing that. And so we're just pulling metrics from vCenter instead of going right to the specific, from the VM, because vCenter already has those metrics via VMware tools. But if it is let's say it is a hardware firewall like Palo Alto, then we're pulling the metrics directly from, depending on how that Palo Alto is deployed. So if you have Panorama deployed to manage all your Palo Alto firewalls, we'll connect to Panorama and we'll actually then pull all the data set, the API, we have an API integration and SMP integration, and we'll pull data via Panorama because it's already got all of your firewalls added. It also will pull insights directly from the firewalls if there is no management tool set being used. But as an example, Palo Alto being a perfect one, if you're using a tool like Panorama, which is a central management tool that Palo Alto has for if you have a large firewall infrastructure to manage your firewalls, we will connect just to Panorama and not have to go to each individual firewall because we're getting that data set from Panorama itself. and also is least intrusive and allows us to get the data from one source. The Insights tab widget has 48 VMs talking to the internet. Could that be customized so that you can rename the destination to where the VMs are talking to? Yes, absolutely. So there are integration points where you know if you wanted to give names to those destinations. So we do geo IP lookup. So when you click into the flows, it will tell you like, you know, hey, this is in this country, this city, and so on. So we're doing that type of information. But let's say you wanted to correspond a specific name to that destination or an IP address and so on. You can actually come in under IP properties and subnets, and we have different ways that we can do it. You can actually provide your own DNS zone files. So if you have like a bind file or a CSV, or you can actually download our zipped sample and you can provide that. We also integrate with things like info blocks and other tool sets that allow us to pull those data sets in. You can also come in and define your own physical subnets and VLANs, and you can also define your own custom IPs. So you can come in and define anything within, you know, as long as it's within the RFC for IPv4 and IPv6. You can come in and you can define, and also if you want to correlate them as east-west versus north-south, you can customize all of that. So all of that can be done within the settings so that you can see those destinations and those names if that's something that you choose that you want to do. Done on that one. All right, so next question. When we create a security group, bundling the application VM into a group in NSX, will it automatically get identified here in Verni? Yes, the answer is yes. So if you create a security group and you bundle the application VMs to a group, yes, it will automatically identify the group and the members of that group automatically. So we are pulling the data from NSX. We're pulling it from vCenter. We're pulling it from you know, the VCF infrastructure. So yes, all of that will get auto-populated and correlated, and we will detect all of that, and along with any types of changes, modifications that are made to any of those security groups that you define. So yeah, that is all dynamic and maps out in as those are being modified. How are critical problems defined, by user or by machine learning analysis? So it could be by both. So we have out of the box alerting. So when we come to alerts and notifications here, you can see that we have problems, changes. So these are alert definitions, and then others. And then you can, out of the box, you can see where the severity is set. So these could be like a Palo Alto panorama not registered with an NSX manager. Okay. So as an example, this is where I can customize and say, hey, you know, it's currently critical, but you may not consider that critical. So you can come in and you can click on edit, and you can come in and change the severity level to warning, moderate, or info. That's going to be more based on what you may want to do, and you can do, you know, include, exclude entities. You can choose how those alerts are also sent to you by push notification, email notification, SNMP traps, and so on. Each alert can be totally customized, so you can modify, but these are going to be out of the, you know, these are out of the box alerts so that we detect as problems. A long list, you can actually just search, you know, like, you know, if I did like, for instance, MTU. Here's any alert related to MTU mismatch between the VTEP and a physical switch port. It considers that a warning. VTEP MTU mismatch between a host and an NSX prepared cluster. So these are different alerts that are out of the box, even with HCX MTU mismatch alert. So these are ones that are there. You can modify these, and then you can also add your own alerts. So you can come in and add your own alerts as you create alerts. We have the capability up here where you can actually, you know, click an alert that you want to create, and you can define that also on the severity that it's going to report. From a change perspective, these are the other alerts, and these also will show you any active over the last 24 hours. So where we're seeing, like, for instance, security group property changes, as we were just talking about security groups. So there's 31 here, and it's reporting those as info level from a severity. So these are just changes that are happening. It's an IP address change, a VLAN VM membership change. You can come in again and customize all of these to how you want them to be determined, whether they're critical, info, warning, you know, from the out of the box perspective. and same thing with user-defined alerts. Now, the machine learning piece ties into when we're doing analysis of the data sets, so the metrics and so on, the flows that we're doing analysis on, it's going to take a look at all of the defined alerts and the problems, and it's going to call out anomalies that are detected. And it's going to, if it ties back to one of these specific alerts, it'll tie it to that alert. If not, it's just going to flag it as anomaly and trigger it. But again, those also can be adjusted as far as how sensitive they are. So you can go in, that's actually done in our intent dashboard where you can say, hey, this anomaly is triggering too much. I want to span it to 10 minutes. It has to be a deviation for 10 minutes or a specific amount of metric. Let's say, it's too sensitive. It's tripping if the deviation is only 10 millisecond difference on TCP round trip time. I want to change that to 100 millisecond. You can totally customize all of those and adjust those thresholds. Next question. While looking at flows for hits on a rule, is there a way to drill into the aggregated internet source IP? For example, we know that Verni will aggregate many hits from a source IP and assign the aggregate address to the source. There has been many times where I need to know what the actual source is and not the aggregate Verni assigns. Is there a way of finding out what the actual source is triggering a rule when reviewing flows when Verni assigns an aggregate source IP? So yes, there is. So it will aggregate at specific points, but there are we do have ways that we can actually dive down to the source. I don't have enough time in this session to dive into that, but I can tell you that yes, we can. And if you actually are running into an issue where it's aggregating and you're looking for a specific source, if you open a ticket, our customer success engineers and so on can jump on and they can show different types of queries that will help you drill down to the specific address within the aggregated address. So yes, absolutely we can. It's more of querying down to specific data set related, and it's going to be a query based method that we do it. But yes, we can. That absolutely can be done. Next question, is the anomaly found box based off of all collected data and just showing for the timeline selected, or the data on the anomaly shown based on the timeline selected? So if I select 12-hour period, will it take into account the past 7 days as well when figuring out the anomalies? No, so basically it's only going to look at the data for that 12-hour period. Now, let's say I do it, if I want to expand it further, it's going to then take in obviously consideration of everything further. So if I say 24 hours, 48 hours, a week, a month, it'll pull in all of the different data sets and then give you the alerting and show you the anomalies based off of the time period that you selected. So by default, when you're doing a guided network troubleshooting session, it starts at 12 hours. But again, the range that you choose is going to determine the amount of data that we're pulling. But when if I know that a user was experiencing an application problem, let's say, within the last 20 or last 12 hours, then I can just drill down to the last 24 hours. If I want to go further, then yeah, I can expand that to 1 day and encompass the metrics and all of the anomalies that were detected over that 24-hour period to see if there was anything that was occurring prior to that period, if that 12-hour window is not big enough to be able, and that can be adjusted inside the ticket also. You can expand that timeline. You don't have to come out and do a new ticket as an example. Can we integrate with ServiceNow? Absolutely. So ServiceNow is an integration. So you can come in here under accounts and data sources, and you can come in and click add source, and you'll come down and you'll see here on CMDBs, and you can click on ServiceNow, and you can actually add ServiceNow as a data source. And then here are the instructions, what is required for the list of the privileges and so on that are required and within ServiceNow. Here's the customizing the CMDB configuration, the different versions and so on. But yes, you can integrate with ServiceNow to pull in the CMDB. And we also do have ways to actually send data to ServiceNow or other ticketing systems to generate tickets using either our data bus or using webhooks or SNMP or various different metrics, APIs, and so on because this system does run a full open API, RESTful API, and we can tie into pretty much any system, just depending on what that system utilizes for ticket creation and data, or if it's just wanting to pull in a CMDB. Yes, that is something that is a data source that you can just add right in the product. And last question here is there a simple way to share the troubleshooting incident with other engineers, or do I need to just share the full URL? So within the troubleshooting ticket itself, so if I go into like a in progress, as an example, pull this up. So these are in progress incidents right now, and we can see the application or the entity. So this is telling you the entity type. These are all applications. So if I open up an incident here, we can come into the incident, and we have different ways that we can actually share the incidents with different end users. So we can actually do when we're doing down here, we can communicate, and we can actually use like a call the end user's name out and via IP address, and it will make them aware. You can also provide URL, or the other ways that you can share this is when you go into the incident dashboard, you'll see here where it says actions. So if I want to click share, this will actually copy the incident link to the clipboard. And then you can actually, like, let's say I was using Slack that incident link over to somebody or email it to them. It really depends on how you want to get their attention. Some users don't have the tool set open 24 hours a day, so they may not get the push notification. So you may want to send it via whatever tool set you're using, Slack, Google Chat, whatever, or send an email with the URL that it copied. But yes, there's different ways that you can share with different members of the team that from the incident, and that can be shared across multiple members. Again, the as long as the end user of Opstra networks that's coming in to do troubleshooting has access via, Active Directory as an example, they can log in and access that URL and dive into the ticket that you sent them and referred them to. And then you can also see where people have started leaving notes, and then root causes, or someone's flagged a root cause, and so on within specific tickets. So you'll notice that we have that also that we can call out. Okay, so done there. All right, so I know it's a lot of information, a lot of data, and I know we're at the end of our time. Are there any other questions before we wrap this session up? And again, if you guys, determine that you want to do another session and go deeper into other stuff, we can absolutely do that. Again, I wanted to kind of give a high overview of the guided network troubleshooting tool, how we can mind map data set to any specific component or even an alert, and show the dependencies and any other anomalies that we're detecting, so that we can simplify the troubleshooting process, or help simplify the mean time to innocence when we're troubleshooting an incident, so that we're not looking all over the place and we have anomalies that are already flagged and called out that we need, are trying to draw our attention to take a look at. If you integrate with ServiceNow, any updates will be propagated to ServiceNow. Yes. So if you make any updates, it will propagate to ServiceNow. Yep. And you can choose that if you wanted to or not. That is, you can define that. No problem. Can it show source and destination ports between two devices? Yes, it can. So you can come in and we can do queries. I can specify a source and destination. I can say, between this source and this destination, show me, or these two devices as an example, what are the source and destination ports specific to those, and what flows are being utilized, and so on, and traffic that we're seeing across those ports, and isolate that down, even down to a specific port if I wanted to. There's many different ways that we can do that. We can do that using a lot of the built-in graphs and so on, and that we have. And then we can also come in and we can do, a query where I can just say, show me the source and destination ports between this device and this device, and it will give me all of that. Do you need any additional license for snow integration? No, you do not. If you have VCF licensing and access to ops for networks, then you do not need any additional licensings to integrate with ServiceNow. There is no, in the past, we used to have our old advanced and enterprise licensing. That is more of that's been eliminated, and it's now just one big, basically everything in the product is accessible as long as you have the licensing for VCF. So it's done. Can you show me an example? Yeah, let me see. So like for instance, and I'm just trying to think of 2 devices I can pick in this lab. Yeah, I can do like, something like, let's say I want to do it by flows. So if I do flows, where source, and then I can do, as I specify each one. So as I do like source, I can do either IP or device as an example. And it will also provide you suggestive. So you can do where as an example, and then I can say, I want to do an application, or if I want to do a device. So as you start typing, it'll give you suggested alerts. So flows where if I start typing source as an example, it's going to say source application, or it's going to say, as we go further down, a specific port or device, and so on, host, IP address, and so on. So let's say I choose a host, and then I say equals, and then I pick one of my hosts. And then I say, okay, and so that's where our source host equals and destination host equals, and I choose a different destination host, and then I click on the search. It will show me any flows and all the ports and so on. And then I can also group this and say order by or group by, and then I can say port as an example. So if I start typing, you can see port, and you can do port display, port name. So depending on what you want it to do, and then you can also expand that time range. This is just looking at currently now, but I can say, let's do it over the last 30 days, search, and I can see if there was any types of flows in what they were grouped by. Now between these 2 hosts, there was no flows going between them, but this is an example, a query where you can actually choose devices or IP addresses and be able to see all of the data set. And then what you can also do is, if this is a query that you constantly want to run and save, you can also save this current search. So when you click on that, it'll save it to each individual user's saved searches. So when I clicked on save searches, now here's that query that I used, and I can automatically pull that up. So when I come up into my dashboard here, I can come in and I can choose save searches, and it also will show you your save searches right here, where I can click on different searches that I've done and have ran in the past, and you can immediately pull those up. So it'll basically bookmark those. What about licensing needs for adding network infrastructure like switches, routers? No licenses required. So no additional license required to add any physical networking devices. We used to license by CPU, and we used to license by devices in the older days back when it was vRealize Network Insight. That has been done away with. Now under VCF, as long as you have the VCF license, you can add as many networking devices you want within the underlay, as long as obviously the architecture of what you've deployed for ops for networks supports that amount of devices. And again, that scales also on the fly. So depending on the amount of devices that you're going to add, you would determine how many platforms and collectors you would deploy within your infrastructure to support that size of a network infrastructure. But no separate licenses anymore. Is there a typo in your query? Flows where oh, yep. There is a typo, but it will actually autocorrect itself. So if you do have it, it will. But yes, that is a good call out. Can we define certain ports as Trojan ports and have alerts to notify about traffic originating from these? Absolutely. Yeah. So you can actually say flows where, as an example, we can come in here and flows where uh, source port equals, and back this out and retype this. Flows. And we'll do where, and we'll do source. Oh. Source. I'm sorry, flows where, oh, you're putting me on the spot here. Port equals, and then I can put in a value number. So let's say I want to put in a range of ports that are known that you want to be flagged or alerted upon, or a specific port. Let's just say I'm just going to, just use 443 as an example. And then I click on search. So now it's going to show me all the ports. There's, we're 2,800 flows coming in on port 443. If I wanted to create an alert on this, then basically you just click on alert. And then what you can do is you can, I'm sorry, right here, you're going to click on define alert. And then here is the search query, flows where the port, and then you can actually tell it where you want it to alert. So if there is a change in the results or the search results is 0, you can define if you wanted a problem or change, the severity, and then you can also provide notes down here related. So let's say it's a specific known Trojan port. You can define that notes there, and then you can determine how you want to be alerted upon that. So push notification, email notification, SNMP trap, and then you can save that alert. So this is where you can actually define, this is what we call user defined alert. So you can do that on any query that you do just by clicking on the bell here, which just says define alert, and it will utilize that query. So you can specify ranges of ports and so on. Yeah, Trey, good point. Good point. It's not source. You don't define the source port. You just define the port itself. Let's see. Example flow VM and source IP not. Let's see here. So give me an example. Lower destination. So you could do lower destination. I can't type today. Jeez, oh Pete. So destination, and then we can choose the destination VM. So destination VM equals, and then you can do the VM name. Yep. So we can choose, see, let's just pick on this one here. And yep, and you want to do source IP address? Yep, source. So source IP address. And then you can do not in, you can do does not equal or equal. Or you can say is not within a specific subnet. So you can define that here. This is where you're going to define your flag, and then you can put in that range, and then you can do group by source IP address. And sort in source IP address, not in. Yep. If you add a physical device outside VCF, will traffic flow west to east be monitored as well? So yeah, if the traffic that is going, so there's a couple different things that you can do there. If you had a physical device outside of VCF, if the traffic, so what we consider east to west traffic is going to be, traffic that's going from overlay to overlay, as far as like east west. VM to VM would be, like a east west traffic. North south is going to be VM to, let's say, the internet, or VM to a physical IP outside of the actual virtual infrastructure. Now, when you do a physical device, if you send the flows from the physical device to the physical flow device collector, which is a virtual appliance that you can deploy, you can set your IP addresses and your subnets to be identified as east, west, or north, south. That is actually going to be under the IP properties and subnets. And then that's where you can come in and you can do custom IPs. And then here's your east, west IP ranges and your north, south. So if you specify those in that use case for physical devices, it will classify them as east, west, or north, south. It will automatically classify it east, west, north, south if one of the flows traversing that outside physical device is a member of VCF. So let's say a VM or Kubernetes service and so on. It will then be able to say, hey, we see this as a north, south, or east, west. And you can also utilize this as a way to, let's say it's calling it north south, and you want it to be referred to east west. You can also modify that in here by specifying that and customizing using custom IPs or physical subnets and VLANs, where you can come in and specifically add a specific CIDR and a VLAN ID and so on, and specify those. So yep, it will do that. Okay. All right, so we are past our time. I do appreciate everybody joining and all the great questions. If you have any other further questions, please feel free to reach out to your TAMs. They can get the questions to me. I'd be glad to answer them. And again, if we needed to dive into a further session, deep dive, I'd be glad to do that. The folks here, Brian and Chris, know how to get a hold of me, and we can set something up in the near future. I do appreciate you attending. Hopefully you guys found this informative, and have a good day. I'll hand it back to you guys.
All right, thanks, Matt. I think you stole my wrap up talk track, so definitely appreciate your time and appreciate everybody's questions and participation. We look forward to seeing everybody again next month when we discuss more about VCF automation. Thanks.